That's the earliest. Total number of exam questions given will be 12, right? Based on your course of study, duration will be 15 minutes. Right, so for this lesson, at the end of the day, there are a couple of key points that you want to achieve. Okay? The first key point would be being able to interpret drawings. All right, drawings. Drawing is uh, well, in short, it's another language. Right, think of it like another language. Malay, Mandarin, English. Right, it is unfortunately it's not a spoken language. It's a visual language. Okay? It's like the caveman. They draw pictures on the cave, give you some indication. You're supposed to interpret what he's trying to draw, trying to express. That's the only form of communication in the old days. Right? Perhaps people have some form of language, but a picture, they say, is worth 1,000 words, isn't it? Right? You go to an art gallery, you look at a picture, it is more than 1,000 words because 10,000 people look at it. They got 10,000 different opinion about the drawing. Is it? Anyone ever been to an art museum? Maybe some of them will go and appreciate Van Gogh's painting, all right? Others are more abstract. They like modern painting, very abstract. Okay? Now, those are also drawings. Those are different kind of drawings. Those are not engineering drawings. You want to have a drawing, you expect people to interpret the way they want to interpret. That is very artistic. That's fine. There's no place for the engineering work. Right? So therefore, we must standardize it so that the same drawing read by somebody in UK, somebody in India, somebody in Australia, right? They interpret the same way, right? One common language, right? And that's the way it should be recognized, right? It is first of all pictorial in form. Okay, there are some words, right? But it's not spoken, right? It is narrated through a picture and maybe some symbols and some words, right? And therefore, we need, as an engineer, you need to be familiar, right, with the at least some basics. Okay? Then, within these basic constraints, right? However, there are still different interpretations as the way to represent them, even though we have an ISO standard, right? Why? Because the big players are in the market today. There's only two big powerhouse, right? Engineering is concerned. Because other countries are catching up, but the form was developed in the West, right? First by continental Europe, then by the Americans, all right? So over the years, they have harmonized, they have agreed on some convention, but there's two conventions that exist today. It's used in different parts of the world, and that's the first and the third angle projection. Okay, what is this? Later on, you will find out a little bit more, all right? And then, as I said, drawings you can have many forms as well, right? It could be a 2D, it could be a 3D, right? It could be a cutaway view, and so on and so forth. Two major ones stands up, and that's isometric and orthographic projection. You need to be familiar with these two. Okay? Not just being uh, able to know what it looks like, but able to convert between isometric to orthographic and vice versa. Okay? Each has its own usefulness. In a maintenance world, most of the time, isometric. Why? Because it gives you a very good pictorial view on exactly how an item will look like, being assembled, right? And so on, right? But in the case of orthographic, it will be very useful if you are, say, a machinist. Okay? Both combined even better, right? So you can have both views. Right? So part of our job today is to be able to jump from one to the other. Okay? If I give you an isometric drawing, you must be able to produce an orthographic drawing. If I give you an orthographic drawing, right, you must be able to produce an isometric drawing. Right? But 90% of you will be more interested in nowadays being able to read and interpret engineering manual, either engine related manual. This is the easy part. Okay. So you're going to be looking at that as well. Okay. We also be looking at maybe some typical Rolls Royce drawing. Right. You are not in the production world. Right. So you are not in the manufacturing world. Right. So some of these drawing could be a bit more it will be most of it simplified. But if you are doing manufacturing, and the drawing can get a little bit more complex. Okay. Nevertheless, you'll see we want to visit those areas okay, a little bit, right? And then be able to, as a technician, as an engineer, right? Your job, besides interpreting, you'll be able to relate to another person, especially let's say during shift changeover. All right. Uh, in this case, you are not required to use AutoCAD. Now, in a modern world, everything is done on machine by machine. But you should still have the ability to develop some basic hand-drawn skills, right? So as you are going through this course, maybe it's a good start. Before I continue, can I just have a show of hands? Who has not had any technical drawing training before? Hands up. Show of hands, please. For those who have not gone through a typical engineering, technical engineering course on drawing. Only one. The rest of you can leave the class now. What am I doing here? If you already have a knowledge. Anas, today I will do a one-to-one review. The rest of them, they don't need to know. Okay, Anas, can you explain to me why is it that you have not done any engineering course on drawing? Why the rest have?
No, sir. Actually, I have, but I forgot. I
Huh?
just
You
want to.
forgot?
I just want to revise.
Okay. So you have, it's just that you
Oh,
forget, Yeah. So if you have already done it, right, this course is a revision for you. Okay. So everyone should have. If you don't have, then I can only say one thing. Your learning curve will be a bit steep. That's all. Okay. Some of you may encounter, even though you may have, some of you may still encounter some problem along the way. It's okay. Right? This is the time for you to pick up where you forgot, where you don't know, and then move on from there. All right, that's the intention. It's not going to make you an expert in one day. I spent many sessions in secondary school doing this. Even after I left school, right, I don't practice, I forget. Right, it's all about practice, being exposed. Okay, yeah. But today we just need to make sure we meet this at least. Right, out of these six, we must be able to meet at least four of the objectives. Right, in order to pass the exam. Right. So a bit of hand practice will help. Uh, some of the better ones, I'm quite sure. We got a couple of graduates in the class, right? You may have more detailed experience in the university. If you are from mechanical engineering in particular, right? You will definitely need to be exposed to AutoCAD systems, okay, mainframe system on drawing, right? Again, I had that experience in the university, but when I didn't use it for about 3 months, when I went back to university, I totally forgot how to use it. So it's about practice. Concept is fine. When it comes to actual practice, learning a software can be a bit more challenging initially, but once you start picking it up again, it should be quite okay. All right, as long as you have your basics behind you. Not difficult. All right, and it can be quite fulfilling as well. Imagine you can draw a complex uh, engineering piece of drawing, right? And then you put it together with proper drawing symbols. It's very satisfying. End of the day, what's more important is whoever is reading it should be able to interpret what you have drawn and able to duplicate what you expect them to do. Okay? So that means drawings are very important. Usually drawings where we go through a couple of different processes, right? The person who sketch it, right, on paper, then tell that to the draftsman then com, uh, com, convert it into a proper engineering drawing with all the proper dimensions, right? And then after you've drawn it, somebody need to check it, and after the person has checked it, somebody has to approve it before it goes in the production floor. Because one mistake you make, the whole batch of product will be wasted. Might not be able to salvage it. Okay? So of course, along the way, you may have production engineers who may be given authority to make on the spot kind of decision to change any production needs without going through the hassle of going back to the drawing office and so on. And that can be a bit more, but it all depends on the system put in place by the company. Okay. And like I say, if you are working on a shop floor, the most you need to do is just a sketch. But at least it's a proper sketch, right? Whether it's 3D or 2D, whoever look at your sketch should be able to interpret, all right? And then that message is well conveyed. Because sometimes you don't have the luxury of face-to-face meeting, right? Where you can conduct a briefing with the guy. If you have, that will be good, right? It reduces the gap, okay? Reduces the gap on any miscommunication. But if you don't have, the only best way you could do is to use a drawing to explain, right? And if your drawing is non-standard, then obviously nobody's going to understand you. Okay, so that's the premise I'm working on today. Along the way, if you have questions, please ask. Right, that's the only way to learn. Right, right. So now that we know what we are going to be expecting, right, maybe you just watch this short video, okay, and then after that, I'll explain certain basics, and then I will divide you down into groups to do your own exercises. Okay?
In this Easy Ed video lecture, we will learn what is
Can you all
engineering
hear?
drawing, drawing instruments and its uses, and lines and types of lines.
Yes,
First, we will see what is engineering drawing. Engineering drawing is a type of
Sorry?
yes, we can hear.
technical drawing which is used to clearly define the requirements for engineered items such as views, dimensions, and necessary information. More than drawing pictures, it is also a language, a graphical language that communicates ideas and information from one mind to another. Most important, it communicates all needed information from the engineer who designed a part to the worker who will make it. Application of engineering drawing is used in ships, manufacturing, aerodynamics of automobiles, constructions, etc. Let us see different drawing instruments used in engineering drawing. In this we have a drawing board, drawing paper, pins, clips, or adhesive tapes, pencils, T-square, set square, scale, drafter, roller scale, protractor, French curves, compass, and eraser. Hey, it's time to concentrate now. Now let us describe each and every instrument. Drawing board is rectangular in shape and is made of wood about 25 mm thick. It is cleated at the back by two battens to prevent warping. The surface of the board should be smooth and it is used to keep the drawing paper. There is a working edge at the side of the drawing board. While selecting a drawing paper, we have to be sure that the size of the paper is smaller than the drawing board. To hold this drawing paper, we use pins or clips or adhesive tapes. Pencils are basically used to draw. The accuracy and appearance of a drawing depends on the quality of the pencils used. The grade of pencils, H, 2H, and HB are mostly used. Next is the T-square. It is made of two parts, the stock and the blade, which are joined together at right angles by means of screws and pins. T-square is fitted at the side of the drawing board and it slides along the edge of the board and is used to draw horizontal straight lines. Set square is triangular in shape with one of the angles as right angle. Two forms of the set square are generally used. one having angles 45, 45, and 90 degree, and the other is 30, 60, 90. Set square is a combination with T square is used to draw lines at an angle. A scale is used to draw lines of specific length. Protractor is flat and semicircular in shape. Its circumferential edge is graduated to 1 degree divisions and is numbered at every 10-degree interval and is readable from both the ends. The protractor is used to draw or measure angles. The combination of a T square, a set square, scales, and a protractor is a drafter. Its one end is clamped by means of a screw at the edge of the drawing board. The other end is adjustable. It has a scale which is at 90-degree and also has a protractor which can be rotated at certain angles. This scale can be moved anywhere we want within its limits. Next is a roller scale. It has a roller in it. It is used for drawing vertical lines, horizontal lines, parallel lines, angles, and circles. Next instrument is the French curve. They are made in various shapes, one of which is shown here. French curve is used for drawing curves which cannot be drawn with a compass. It is used to draw curves like ellipse, parabola, hyperbola, etc. A compass is used to draw a circle of a specific radius and an arc at a specific distance. Soft Indian rubber is widely used to erase pencil drawings. The eraser should be such that it does not spoil the surface of the paper. Next, we will see lines and types of lines. Just as in any textbook, we are taught to use the correct words for making correct sentences. Similarly, in engineering drawing, the details of various objects are drawn by different types of lines. Various types of lines are used in engineering drawing. Now let us see the different types of lines. First is a continuous thick line. This line is used to display outline and edges of the main drawing. Next is the continuous thin line. This line is basically used for dimension, extension, projection, leaders, hatching, etc. Next is a continuous.
I see some videos missing. You turn on your videos now for those who have disappeared. One more. I'm gonna count to three. Yeah. If I don't see your face, one, two, three. Okay. This is the final capture. If any of you consistently have connection problem, you know what happened, you need to go to Cesar and do your lessons. Otherwise, very disruptive for everybody.
Thin freehand line. This line is used to show short break or irregular boundaries. Next is the continuous thin line with zigzags. This line is used to show long break. Next is the dashed line. This line is used to show hidden edges of the main object. Next is the chain thin line, long dash dotted. This line is used to represent the center line for circles and arcs. Next is the chain thin line with thick at the ends. This line is used to represent the location of a cutting plane. Let us take a quick review of what we've learned in this video lecture. First, we have seen that engineering drawing is a type of a technical drawing which is used to clearly define the requirements for engineered items such as views, dimensions, and necessary information. It is also called as graphical language and helps to communicate. Next, we have seen different drawing instruments used in engineering drawings such as drawing board, drawing paper, pins, clips or adhesive tapes, pencils, T-square, set square, scale, drafter, roller scale, protractor, French curves, compass and eraser and their uses.
How many of you have used any or combination of these instruments before? No? Never used before.
No,
That's it.
Okay. So this is old school, probably in the 70s to the 90s. Right? We have to carry a drawing board with a T-square and a set of other instruments to school every day. But it's a very good experience. All right. Now everything is done on AutoCAD. Right? But at least you still need to know what used to be happening in the drafting office. Right? Today, no more such things. Everything is done on a computer.
Roller scale, protractor, French curves, compass and eraser and their uses. Finally, we have seen different types of lines used in engineering drawing to draw an object. So this is the overview of our video lecture.
Okay, so I hope this video about a little bit old school, right? But give you an idea on at least some of the expectation and outcome we hope to see from you, lah. Except for item 2, right? 1 and 3 would be critical, important, all right? Understanding the lines. And later on, while you are doing it in your exercises, also take the line drawing into consideration. All right? Hidden line, guidelines, and all that, and outline. Try to differentiate it with. If you are doing on hand, then make sure you can see it visibly. All right? Put some of this into practice. Okay? All right, so the purpose of engineering drawing essentially is to convey a message, typically from a designer to the guy who's doing the manufacturing, or from the designer to the person doing some form of installation. Okay, so it doesn't always have to be manufacturing, right? Sometimes it can be assembly, right, or disassembly and so on. All right, and therefore we need to be conversant with some of these things that we just mentioned, right? Terms, symbols, especially symbols, right? Because terms you can still have some idea. Sometimes symbols you may not have, right? Because you know words there, it's just a picture. You may misinterpret, so you need to learn the symbols. Uh, Abbreviation, yes, quite similar to terms and symbols, right? But now it's written, okay, in short. What does it mean? Right? Most of the time, you can make some sense out of it. There might be a 10-15% chance that you may not know what the term means. So you can refer to a chart, right? Or some standard text. And then, of course, the methods of presentation. Okay. There is a standard for that. There's an ISO standard for that. There is also an American standard. There's also a British standard. There's also perhaps a European standard. Okay. Whatever it is, right? 95% of the convention used are similar, right? 95%. I would dare to roughly guess it's about 95%. Okay. So when you switch from one to the other, probably you need to top up. Right? But some industry may have their own unique requirements. So in the case of UK, besides adopting the latest British standard 88, right? They also in the industry, the Society of British Aerospace Companies, okay, also come out with their own standard to supplement the British standard, okay, and that is SBACTS, TS stands for Technical Specification 88, okay. So in other countries, we have similar things, right? So this is this information are from the mainland British, right? So therefore, they're using the adopt the standard, right? But yeah, it doesn't matter. Depending on what your company uses, okay. Some may adopt it, especially if you're in America, then you may adopt the American system. Okay? And Rolls Royce, because it's a little bit more international in a sense, therefore sometimes you do have problems, right? Some of the language used can be a bit more Americanized, right, rather than British. As long as you understand. All right, so there are four main types of drawing in general. These are the four main ones under the British system, okay, and also quite similar to the American system. You have a single, collective, combined construction, 1S and 3C. All right, single part, collective, combined construction. Now, from the terminology, you can understand really straight away. Right, single part means one item only. Your spectacles may be made up of maybe 5 or 6 different parts put together, right? So a single part means only one item, either the screw, the frame, right, the lens, and so on and so forth. Right? So single part, think of it like the Lego bricks. They are the foundation. They are put together to form an object. In this case, in the case of a Lego, right? You get seen. Anyone have been to Legoland?
Not yet, sir.
Not yet. Good. Welcome to the club. I drove past there, but I've never had a chance to do it. Yeah, I mean, most of us are familiar with Lego. If you're a kid, probably your dad, yeah, or your uncle, your auntie may have bought you a set to play with, simple ones. Right? But Lego is fascinating. Right? Some people spend a lot of money just to maybe build an aeroplane or a big structure, right? Make a Lego block. A Lego brick is a single part. Right? You put all the parts together, you can form something, right? A picture, a shape of an object, and so on. Okay. Now, if you have Lego bricks and your Lego bricks are in different sizes, all right, and maybe certain dimensions are quite similar, maybe for the length and width, let's say, right? Then you may not just want to do a single part. You may have 5 different sizes. You can use a collective drawing to produce that. Okay. So it's only for you to go and develop 5 single parts. The drawings are all the same, only the dimensions are different. Right? So that's what you call a collective. Right? Then you have combine. Combine here means what? You're combining different types of drawing into one drawing. Right? Combine. Right? And the last one is the construction. So generally, we think of construction as this. If you have to build something, you have to show the details. So single part doesn't show you how the picture ultimately looks like, right? Because they are the foundation. You have to put them all together. All right. When you have to put them all together, then you can see there is some form of a building construction. All right. So how to construct it? Right. That piece of drawing will show you how it's constructed. Okay. And there are many other types of drawing, but these are the 4 main types. Right? So a complete set of drawing typically will be needed. So to build an aircraft, they say by the time you finish building an aircraft, the paper, the drawing, the documentation, the specification is about the same size as the actual aircraft itself. Okay, for those who have gone through a type course, right, in the training, you may have already seen the amount of documentation in the library covering for one particular aircraft, like a 737, 747. right? It's a whole library of literature. Today, all these are being squeezed into a thumb drive. Then you can pull out the information from the computer, right? But old days, everything is hand drawn, every single page, every single detail, all right, and then put together. So the amount of paperwork is tremendous. Okay. So yeah, computerization has shrunk everything into just the size of your laptop, right? You can see from there all the pages, right? Few thousand, 100 pages into one. Okay. So certain profession, as you can see, from what I've just mentioned, today is really out of job lah. If you are a former draftsman, right, you find that no more office for you to do drafting. Everything has to be, you have to be retrained to do everything online on the computer. Okay, if you are used to just manual reference to your EMs and so on, you find that day is also gone. Today everything is online, right? You do a search, all right, and then you read from there. Okay. Right, so let's look at single part drawing. A lot of details here, very useful. Yeah. Can you all mute your microphone? Thank you. Right, so a single part drawing is what, as the name suggests, a single part. But don't underestimate the power of the single part. It is from a single part that you develop all the rest of the other drawings. If not a single part, right, you cannot produce a part, you cannot expect the whole aircraft, even just for a single part. Right? Let's say a screw or an undercarriage, a component, right? A basic component. If you can't produce it, you cannot see the completion of the entire whole of the building, your aircraft, your automobile, your motorbike. So everything starts from here, single part. Single part provide you very important information. What are they? First of all, the shape, the geometry, that is. Number two, they give you the dimension, including the tolerance. Number three, you have the material. Right? Before the material, you can make this out of wood. You can still work, maybe. But put into an engine, for example, you will not function because it's made of wood. So material is important. Okay. The other information, those to me may not be very critical. Right? Like your scale, for example. All right. And then, of course, a single part drawing number is also usually the part number for the item. Usually, all right. So it's no need for you to again rename it a different part number, right? The drawing number usually is also the part number. Right? These are some of the key points I want to highlight. Make sure you're familiar, right? An extension of a single part is a collective, right? In this case, a collective single part. Okay. In this case, you'll find that it's only one single item. The only thing there's a variation is the length. There is no need to reproduce the length all the time in 10 different drawings. Just put all into one drawing. Okay? And then specify the length based on the part number and the length. Okay? Let's move on, right? Then you have also other form of drawing like assembly drawing. This is a collective drawing, right? Again, it's a collection of different sizes, conceptually the same, right? The shape generally is the same. The only variation in this case is the length. All right, the grip length and the length of the boat is different. Okay, diameter is standard. So if you buy a boat, you want to know what is the grip length, what is the length. Right, so there's no need for you to reproduce everything into. In this case, I've got 10 different parts. Right, so there's no need to do that. Standard parts, of course. If it's non-standard, then you have to specify very clearly. But even for non-standard, you can actually specify here. All right. So this is what they call a collective assembly. Combined drawing simply means combine different types of drawing into one. All right. In this case, I have an illustration of an electronic block diagram, which combine and with a single line kind of diagram. Okay, for those who are in electrical avionics, you are more familiar. Okay, so there's a combine, and then finally construction, right? So to construct something, you need to put everything together in the right place. Dimension is still critical. From where to where, for example, all right? Where you need to drill the hole, where you need to fix the screw, where you need to do your welding, all that can be specified here. Okay, construction, right? So the other examples. So sometimes assembly diagram in another form may be called installation drawing, right? Because you need to install them. You need to install certain parts. For example, you still need to know the dimension, where exactly it should be located, and how high from certain location. So this may be critical, especially on aircraft, right? Sometimes you need to have clearances, gaps, and all that. You need to adjust, right? Installation drawing will come in. Right? GA drawing is a term they use for, as the word says, general. So it doesn't give you much information, but it gives you an appreciation on what goes where. Right? For example, if you are trying to illustrate how an aircraft this may be good, right? You need to introduce the person to the various parts of the aircraft, where the wings are, where the vertical stabilizers, horizontal stabilizers are, where is the engine located, because if you are looking for first time outside, you don't know where's the engine, right? What is inside the cockpit, where is the radar, and so on and so forth. All right. So these are all general arrangements. All right, a general profile, right, of the major parts of an aircraft. You want detail, this one can give you. It only give you an appreciation only, right? But sometimes the first appreciation is important, right? You can buy a car, you can buy a motorbike. The first thing you want to do is the general appreciation first, before you start looking into, what's the engine made, what's the horsepower and all that, isn't it? Right? First impression is very important. You draw the person in, right? He walk past the window, he see this beautiful car. From the outside, he likes it, right? Then he goes on inside to explore a little bit more, right? Whether you have your movable mirrors, whether your seat can be reclined with a massage chair in there or whatever, that part will come in later. Right? But if your girlfriend with the car that doesn't, maybe you'll move, but first impression very important. Imagine the difference between a Lamborghini and a box-shaped car, right? That looks like a delivery truck, right? Nobody would appreciate that, right? But if you're a businessman, then of course different, right? You need to deliver goods, right? Then you'll be looking for the kind of profile. Okay, yeah, this car looks like it can carry a box that is 10 feet tall, right? That's what you're looking for, not a Lamborghini is low and road hugging, the shapy. No, that's not what you want. So GA has its own advantage, right? Then of course, if you assemble a part, then this sort of drawing will be very useful. You know exactly where the part goes in. On the outside, you can't see anything, right? What goes on inside there, right? So this is what we call, if you look at this drawing, basically it looks, later on you'll see in your different sectional views, this is what we call a half section, okay? Because it's cut exactly into a quarter. A quarter of it has been removed, so they can see not only the outside, but also they appreciate the inside. These are good if the parts are geometrically symmetric, right? More useful. If it's not geometrically symmetric, then maybe a cutaway view would be better. Right? Some people may mistaken this for a cutaway. It's still a cutaway view, right? But the terminology used is different in our drawings. This one is probably the type of drawing you see in your EM, right? Very useful, right? So this is good for assembly, exploded view. You know exactly how the parts are put together, right? You have some idea. You may still need to refer to your EM, but eventually by just looking at a picture, right, you will roughly have an idea how the different parts are put together. If you just scrutinize it a bit more, huh? Right? This is the kind of drawing that you will get with the IKEA. If you go to IKEA to buy the product, right? Because you have to assemble on your own. Okay, your chair, your table, your cabinet, right? They always come with a drawing, right? Exploded view. So it's a bit idiot proof. I look at it, you should, but don't take it for granted. Even for computers, which I used to assemble on my own, right? Sometimes the parts are not the drawings and the parts that doesn't quite commensurate, right? So the screw sometimes could be a wrong size, right? The bracket sometimes could be out wrong position. So when you fit it, you may have a little bit of problem. Then you have to use your ingenuity to modify it, but not on our engines. If you are not able to fit any part, as a general rule, do not use force. Okay, all the parts are designed with great precision. If you cannot fit it, right, very likely it is a mistake. Do not use force. Right? There are many instances where people use a brute strength just to put the part together. Either they are wrong or the part is wrong. If you can remove the part, you should be able to put that in easily. Okay. If you use too much force, then something is wrong. You probably uh, there could be an alignment problem, or the size that you're fitting in, or the position you're fitting is incorrect. Okay, remember this rule, Okay, although we are talking about drawing, I want to emphasize this as well, because there's a number of occasions where there were damage, because guys do too much force. Okay, there are other types of drawing you can read through, right? These are typically for the electrician, right? Electrical guys, wiring drawing. If you are a mechanical guy doing A and E, very likely you need to read this, right? This is what we call a circuit diagram. Very good, right, for explaining how the system works. Very good for troubleshooting, right? So you need this. If you are troubleshooting an aircraft and the pilot complains that there's a problem, right? Then you need to be able to use this and then do a troubleshooting. When I say troubleshooting means sometimes you may have to either replace a component to try out, or you have to blank off certain area, check for leak, and so on. Right? Very useful. Right? Then we're going to talk about two very important projection, isometric and orthographic. Okay, this one must know one. This one will give you some practices on this. A lot of practice, not just some. All right. So in terms of projection methods, you can think of it as two types, right? First is the perspective and one is the parallel. What is perspective? If somebody asks you, can you give me a perspective of the world today?
The way we look.
Yeah, you probably put on your glasses and then and you scrutinize all the events that happen, right? Visually, of course. Of course, you can also use your ears and listen to your radio, right? But that radio information gets into your ear, travels to your brain. Your brain is the one that decipher all this information, physical, visual, audio, and then you have a perspective of what is happening. Right or wrong is another thing, but when I say perspective means what you see. Okay? So in real life, an artist painting is always perspective. What he sees, he paints. He paints the scenery, he paints a portrait usually from what he sees. Perspective view generally. Okay? Whereas parallel is different. For engineering, we normally use parallel. Okay? Because what you see is not what you see visually. Your brain will say, yeah, this is correct. But it's not exactly what you see. Okay? I will explain this to them a bit more detail later on. It's a bit confusing sometimes. Right? Perspective, think of it like an artist view. Or even if you're not artist, what you see. Okay? You look into the horizon, right? Today morning you wake up, right? What time you wake up this morning? Some of you probably 8:30, right? Yeah, but for those who had to travel all the way to Asia, you probably had to wake up at 6, huh? Right? So along the way, as you travel, what do you see in the horizon? The first thing you see is the sun, right? Then maybe you have a visual indication of Singapore, right? Then as you go nearer, you can see the causeway. You can see right in front of you is the immigration office. Right? But far away is the sun, right? Your eye is seeing things, right? This is the perspective of what is going on. When you draw exactly what you see. Okay. But in engineering drawing, you don't want to do that, unless you're an artist. So usually you use parallel kind of projection, okay, so that people can see well without any kind of distortion. Yeah, because the sun is so big, but what you see is only a dot. Okay, it don't make sense. All right, so you can further break that down into the other categories. Axonometric is what we will be looking at. One specific one is isometric. Right. On the other extreme, orthographic. Right. So one is 3D, one is 2D. Right. In the case of 2D, you'll be looking at a first and third angle projection. In between, there's a combination. Okay, there's a combination. So that we call it oblique. Right. Oblique drawing. There's some differences here. So later on, we'll look at it in more detail. Right. So this is an oblique drawing. Right. Typically, you will see a 3D object being drawn onto a 2D piece of paper, right? Whether it's a screen or a piece of paper, right? But you see it's only, you don't see a 3D, but actually the representation on a 2D piece of paper, right? The paper only got length and width, right? But it's one more height. So you can represent it in a 3D form, right? That's the beauty part of engineering. Right. So in terms of picture wise, right, if you look at it from the perspective of a human eye, right, we can break them into the three main types: perspective, oblique, and isometric. These are all picture form, just like you saw, right? Perspective, oblique, and isometric. Right. So these are the three main types. Okay. Isometric is the one that is most frequently used in engineering. The artists tend to use either these or sometimes even oblique projection. Okay, what's the difference then? Okay, so there are a couple of important points you need to note. In the case of perspective, let me show you a picture first. This is a perspective drawing. It sits between isometric, right? In a way, it is quite similar to an oblique, right? The only difference here is this, right? In the case of perspective, right, you'll see that these two, right, this side and this side is parallel to the edge of your drawing, whereas the receding line, the depth, right, is projecting towards the horizon. This is called perspective. Okay, the horizon is what we call a vanishing point. Yeah, there are variation of this type of drawing. I won't go into details, right? Otherwise, you get confused, right? But just show you a simple one, right? This is a perspective drawing with a vanishing point. In order to draw these lines here, right? I need to locate the vanishing point first. Where do you want the vanishing point to be? Is it here, 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 or multiple vanishing points? Okay. So in this simple example, let's say there's one vanishing point, right? You have to locate it very far away, like where the sun is, and then you project from there. You draw backwards, to touch this point, this point, this point, and then from here you have your projection line. This is what we call a receding line. Okay, so far. Okay. So most people may get a bit confused between perspective and maybe even isometric. Yes. Somebody got a question? No? Okay, I saw a hands up just now. Momentarily, and then it vanishes. All right. So as you can see here, the front face of the object is parallel to the picture frame. Right? The front face here is for the front face, parallel to the frame. But this one is not parallel. It vanishes. So it's tapered in a sense. Right? So there are some important points to note. In reality, right, you cannot go and locate this point far away and then put it in a drawing. Difficult. So maybe in a drawing, you just make some assumption that this point is here. But when you draw the picture, it looks something like that. Because it's only the area of interest. Okay. Then of course you have your isometric. Isometric is also 3D, but you will find that the front face is aligned. This is the front face, or this is the front face. It will be aligned at 30 degrees to the horizontal. And the other property is all the lines are parallel. Okay, so this is a variation. Right, so this baseline it must be 30 degrees. No other standards. So isometric is standardized to 30 degrees. Okay, this one you will take note. Very important. For sketches, you don't bother lah. You just roughly. But in your engineering drawing, this has to be 30 degrees. All right, and then of course we talk also about oblique. Oblique looks a little bit like perspective, right? Only one difference. Okay, oblique lines are parallel. That's why just like we saw the chart. Oblique is under parallel rather than perspective. Okay, and it sits between isometric and orthographic. Okay, this line here, this front face is parallel to the frame, but your receding lines are not. Okay, but having said that, they are parallel. They are parallel. They are not as in the case of your perspective drawing. We have a vanishing point. Okay, this one doesn't vanish. What does it mean when it says doesn't vanish? What is saying that if you draw the line, you project it all the way, they will never touch each other. There's no vanishing point. It can go to the end of the universe and back. The lines will still be parallel. Clear? All this basic concept. Another property that you want to note, very important, right? The angle here. This angle here that you're going to be projecting can either be 45 degrees or 30 degrees. No restriction, okay? 45 or 30 degrees. Whereas in the perspective, it can be any angle. Okay? You choose. Because sometimes you have multiple projection lines. Even one right at the top also, right? For your projection. So really depending on where you want to choose. But for oblique, right? Standardized 45 or 30. Only two options. One more important point that you need to note. Receding lines here. Okay. In this case, the receding lines are drawn to half true length. So in other words, if an object is 1 inch, your receding line will only be half an inch. Half true length. 50% discount. Clear? So take note of this. The one in red are your receding line. Okay. Actually, this should be 2 inch, but in your drawing, you show as 1 inch. Right. So two important points here to note. Three, in fact, considering that this has to be parallel, it's not vanishing. Second is the angle. The third, the length of the receding surface line. Right. Right. That is 3D. Now we look at 2D. 2D can be a bit more complex for some of you. You need to be able to visualize. Visualizing from 2D to 3D can be a bit complex. But it's very, very satisfying once you're able to visualize from 2D to 3D. That's what you're going to do later on. Right? From 3D to 2D is easier. From 2D to 3D, a bit more complex. Okay? Why? Because in the case of 3D, 2D, right? First of all, you need to understand what is first and third angle projection. Okay? Never mind about this first. Right? Later on, we can discuss. Right? Let me show you. Right? These are the answers. I'm not going to show you. Right? In reality, if you are doing a six-sided object, for example, a dice. If I ask you to represent in 2D, right? If I ask you to do it in 2D, you need to draw three. Usually, you have six sides, right? You can see the front is a three dot. The plan or top view is a two dot, right? The side view, right? The side view or the end view. In this case, if you're looking from the right to the left, is a one dot. If I ask you to draw this and then I show you that the three dot is a front view, right? You would actually draw the front view first. Take note, you draw the front view first. Okay, let me try to recreate this, by drawing it. Then hopefully you can follow. If I put an arrow here, I say this is the view. The arrow usually will give you a starting point, because you can start anywhere actually, It's a bit more complex. So now if I tell you this is the front view, it's easier, right? So the first step is I would draw a rectangle with three. Always start with the front view. And then if I need to draw the top view, I look from the top, right? If this is the third angle projection, I will draw this here. This is what I see. And then if I want to draw the end view, right? This is what I see. I will draw it here. This is my first angle projection. Is it clear? Steps are important. Don't just anyhow, don't draw them in a straight line. When somebody tells you to do an orthographic view, you do it this way. Right? For those who have forgotten, please review. Okay. So this is what you're going to be doing, right? In reality, you can actually go up to six sides, but there's no need to show all six sides. For example, if I look from the bottom, what do you see at the bottom? Anyone can tell me? Can anyone tell me what's at the bottom? View. Come on, you should know, right? What should this be?
Okay.
Huh?
Two dotted line. Two dotted round.
Is it 4, 5, or 6? It can't be 1, 2, 3, right?
4.
4. Okay, so somebody say it's 4. Who say 4? Who say 4 just now? Amiruddin.
Yeah.
You're a gambler, I can tell. Okay, what about this side? This way here.
5.
5, right? Okay, what about this side from the back? Sorry. You don't see, yeah, from the back. Only one left, not much choice. If you say this is 4, 5, this one is 6. Right? Do you need to show everything? No need. Amiruddin, he knows everything. He can feel it. If you hold the dice, he can feel the dice. Yeah. Mahjong players are like that. They don't need to see the style. They just feel it and they say, yeah, then they just show without seeing it. Okay? But in reality, you will need to in some cases. Okay? Right? Because this happens to be the conventional dice. So it's arranged this way. But it's not a conventional one. You want to design one for your own, you may change the placing for 4, 5, and 6. Then you need to show. Otherwise, nobody know where to put the 4 dot, 5 dot, and the 6 dot. Is it clear? So in terms of uh, details in your in your orthographic drawing, typically it can give you up to 6 different drawings. Okay, 6 views. But conventionally, we don't need to show all. 4, 5, and 6 in this case typically not required. Okay, because 3 views is enough to provide all the details. Can All right. So these are basic things that you need to be aware of. I think with this, what I'm going to do is this. I'm going to pause here. I'll give you exercises instead. Right? And before that, any question? If you are happy, then I break you into your groups. You do some practices for me. Okay? I got 3 exercises for you. Now, if you are doing the exercises, please, I don't want you to go and Google for answers. The whole idea is for you to analyze, all right, and then think what you view is correct. It's okay if you make mistake, right? Then we learn from there. Is it clear? Yeah. So get together, right? I will try to reduce the group to smaller size. Right? The other day I got 30, so it's a bit too big. So I have to break them in. But today I'll break it into 5 groups. So you got 3 each. Right? Except for one group, you have only got 2. Okay, you get together, you think about it, right? Analyze it. Uh, their PDF drawing, right? So what you can do is you can draw on your PDF, or you can cut and paste the drawing and then put it into your PowerPoint, and then you all get together, share screen, then try to analyze and then produce a final one. Okay, I want you to do it on your own. Then later on we all compare notes. Okay, it will be a very good learning experience. For those who are more experienced, maybe you can show those who are not. Right? If everybody is all blurking, never mind. Right? This is the time for you to make mistakes, learn from there, and then move on. Is it clear? All right. So let me see. Let me organize the group first. Okay, I tell you what. I change of plan. I will set up the channel. When you come online later on, then we move over. All right. For now, let's go and have a break. Okay, a good break. I will give you 20-minute break. Then you are fresher. Then we can start. Okay. So time now 9:50. Let's be back by 10:10. Okay, sufficient time for you.
Thanks, sir.